Welcome to the Anti-Pattern Podcast, your ticket to the revolution in digital thread technologies. Please welcome, live from Mannheim, Germany, your hosts, Christian Muccio and Michael Fenning.
Hello and welcome to the 15th episode of the Anti-Pattern Podcast. Today from a very sunny, very hot Friday in Mannheim.
And sweaty.
Yeah. Yesterday I thought about our journey to Florida 10 years ago.
Oh, yeah.
It was kind of the same weather here.
Similarly humid. Yeah. Probably true what you say.
9 or 10 years ago, yeah. Okay, so today we have the second part of our Theory to Practice series. And of course, we collected a couple of points for you. And what do you think, Michael?
Yeah, so we said theory to practice that usually should go together, right? And what you need to be really successful is actually a feedback loop between the two, right? So meaning that you validate, verify, if that's possible, your theory in the real world, right? And then that you take that feedback back into your theory, right? So the theory is not done once you conceptualize something and then, test it against the real world and then hopefully everything's fine. Yeah, that's not how it works, right? There needs to be a feedback loop between theory and practice, right? And in other words, what we try to do today is we look at things that we learned not in school. Yeah, so something that you were not prepared for, if you have a hard time understanding why this is the case, right? But it's there and you have to deal with it, right?
Right. Yeah, so getting to the first point, which is software is more about people than I thought in the beginning of my career. So there is this saying, all business is people business, and that's really true. So
it's also true outside the software domain, yeah?
Absolutely. But especially for us in the software domain, there are a bunch of people dealing with you and your software. It's people who develop the software. It's people who sell the software. It's people who buy the software. It's people who use the software, who install it, who run it. So in other words, or to say it more in a systems engineering word, there are so many stakeholders you have to care about in the one or the other way.
Yeah, and funny enough, and I guess we said it before, people are not machines, right? So it's not only about rational thought, so to say, right? And if you lead a team, right, you have to deal with the balance in the team, that everybody is on board, right? That people want to work, people are motivated. And I would even go so far and say, one quote, I'm not sure who did it, right, where this is coming from, but I heard people are the source and the solution for all problems, right? So sometimes computers just solve problems that people created, right? And if people didn't create the problems, the computer had, nothing to do, right? So this is also something that you need to keep in mind, right? First time you enter a real IT project, right? You see a small portion of the problems you are solving are actually IT issues, right? And a big portion is the project itself, is the communication, is the change process, is the motivation in your team, right? All that kind of stuff. And usually it's actually the bigger portion, right? The technical issues are usually, of course, there are big problems out there, but usually they are solvable, right? And those people problems, I feel like they are never 100% solvable, right? They only can be mitigated, something
and the problem is that they might be irrational. And a technical problem is a rational problem, usually.
Yeah, so, and that brings us to the second thing, which is also not really rational, right? And that is, I tried to explain this to programmers over the last years. And that is a misunderstanding that the best product will always win. This is what they think, right? And that's not true, right? Because they will say something like, why do we need marketing? What do we need marketing for, right? Our product speaks for itself, right? Speaks for itself, and it's so great, and everybody will use it because we solve all the problems better than anybody else, right? And then I asked them the question, okay, if that's really true, how would you explain that the most used operating system in the world is Microsoft Windows, right? Windows was not the best operating system back then, right? VMS was way better, Unix was way better, right? From a pure software perspective, right? So in other words, don't think that just being the best one in terms of your product will make you automatically win, right? That's not how it works. You need marketing. You have no benefit from a great solution that nobody knows, right? You will fail anyway.
Right. Another point is what we learned in last couple of years, that you never should underestimate the migration projects.
Oh, yeah.
So if you have a project with migration parts, it's always a pain.
Yeah.
And it seems easy in the beginning.
Yeah.
So even if the data model fits, you don't have to deal with any new fields, or you can even you can just take any default for a new field that wasn't in the old system but now in the new system.
Yep.
Everything looks fine, and then in the end you find inconsistencies.
Yeah.
So inconsistencies in data is a usual problem in these migration projects, and and you could even say, look at the data before you import it. Yeah, but then I have done 80% of the job. True. If everything is fine and consistent.
Yeah, and people forget it's not only about data, right?
Yeah.
The data is the one thing, right? And then people look at it and say, oh, that's easy. It's called something here, and in the other new system, it's called something else, and we can just, mapping, and then, import, export, and that's done, right? That's not how it works. Even if you don't have any customization, by the way, right? The bigger problem usually is the business logic, right? If it's not the same, if you use or lose functionality, right? Then you need to add that functionality because people are dependent on it, right? And then it's getting messy usually, because most times the tools involved are not made for customization, as we already explained, right? So this is also an issue then, and usually you don't see it up front. You only learn in the project without having to look. Or in other words, you will only learn in the project all of the details that you need to know to really do it, right? You cannot theorize about it.
Exactly. Yeah, that's the point. In theory, it looks easy. In practice, you see the problems. Yeah.
Sounds like the theme for our two episode theories. Yeah. So right, and then coming to the next one, simplicity is your friend. This goes back also to, I would say also MBSE is a good example for this, right? In school or university, you learn all of the different things that you need to know, all those concepts, constructs in, a modeling language, for example, right? Or any other concept that you learn theoretically, right? And usually you tend to get big in your understanding, right? You want to understand everything, right? And everything is usually very big. And if you then come to the real world, you will realize very, very early on that the best winning concept is a concise one, and it's actually a small one that you then implement, because you need something small to scale it, right? A lot of people need to understand it, right? Not just a few, right? And then you can start scaling it. Then you can make it a little bit more complex, right? But the more complexity you add, the slower you get, right? And this is something when you never really were part of an big scale software development project, you don't really see this as a problem, right? You learn it on the job, basically. That simplicity is basically your friend.
Yeah, absolutely. Yeah, which definitely fits to the next point, which is things may take longer than you expected, and there are various reasons for it. For example, on the one hand, much of these projects, software projects, implementation projects, are a creative process. Right. And a creative process isn't just waterfall. And even if it would be waterfall, how would you know from theory how long a stage takes? And this is what we encountered, that learning comes more from doing than from theory. Yeah. In theory, you can think about these problems, but in the end, by doing things, you see the real issue, why things take longer, why you have to wait for other tasks, and so on. So Yeah, basically.
Yeah, take an example, an existing platform, whatever it will be, some enterprise software platform, right? And you have an issue, a small one, right, that you want to solve. You can theorize about it for hours and days and weeks and describe everything you want to bring to the table and solve the issue, right? And then afterwards, after you've done that, let's say for 2 weeks, right, then you go into the system and then you will realize, that's not so cool because a lot of stuff I thought about is actually not working because you have other constraints in the system that are preventing you from doing it, right? So you learn that then after 2 weeks, right? And that's something you should have known before, right? So in other words, if you start with something small, high level, right? Something that you want to try out, a small portion of the actual concept, right? And then try to realize only the small part. You will encounter constraints. You will see, it's not as easy as I thought, right? And then you iterate through it, right? And this is the way how you learn because you always, as we said, get that feedback loop, right? From reality, right? From the practice back into the theory, and then you optimize, right? This is the way better approach.
I've seen that so many times that projects were planned and planned and planned before starting, and start small, fail fast is the much better approach.
Exactly. Yeah, and then you can get rid of projects that are not successful, right? And don't waste your resources on something that was not a good idea. Yeah.
Right.
And then coming to the next one, this is more about people again, right? And this is in the real world, there is not one single person that could develop a enterprise software application on its own. So you always need a team. That's a really critical thing for many programmers out there. You need a team of people, right? Because one individual is not capable of developing everything, right?
Yeah. Very seldom, maybe B2C.
Maybe.
Some app, some game.
Probably.
It might work.
It might work. Definitely not in our space. Right?
Exactly. Our
space is way too complex. So you always need a team. And what I then try to explain to programmers in the past is as this is the case, you need teamwork, right? And you need to communicate with the other team members, right? To find together a solution and that everybody's on the same page, that everybody learns from each other, right? And that you kind of create ideas together, right? Someone comes up with an idea, the next one, right, is triggered, right? And comes up with something in addition, right? And then you iterate through it, right? In a collaborative process, right? What that means basically is it's actually, and sounds harsh, but it's true in my view, is if you have no understanding of a subject, right? Or if you are very clever but are not able to communicate about it, it's basically the same thing. It comes to the same result, right? You will not make progress, even if you are one person that is really, really capable of the project, knows what should be done, right? And can maybe even program 50-60% of what's necessary. Then you will still fail because just one resource will not do it. Not just because of time constraints, right? But also because of the creative process that only works in teamwork.
Yeah.
That's something that programmers that were only in university, working maybe on a research project, on some small POC, they will never, or most of them, will not be able to understand this right up front. Right? It's something you need to learn on the job.
Yeah, next point is that only one thing is certain, and it is that requirements will change.
Yeah, actually an old systems engineering joke, I think.
Yeah, and it's even older than systems engineering. Okay. The only certain thing is times change, things change. And the good thing about it is that this kind of empirical tests that you are doing something might help you to improve theory. So in theory, everything goes right, one step after the other, some in parallel, everything works fine. The time plan is set for a couple of weeks and everything works fine.
Right.
And these plans or these theories never encounter that a requirement might change. And that means that you're going back maybe even to the beginning, and re-implement or at least investigate on this change. And most of the times you need to re-implement things afterwards.
Because in the real world, it's really, really hard to, let's say, fix or make requirements static and then just do, right? It's not how it works, because requirements keep on changing, right? And therefore you need to replan, right? You need to reschedule some development work, right? This is just the way it is. And unfortunately, the development team cannot change it, right? Because it's outside of their control. Usually it's the customer, right? Or the market asking for it, right? To be successful. So requirements keep on changing and you need to handle it, right?
Yeah. So your specification is never done.
Yeah, specification is never done. You will always, to some extent, specify. And what I find so funny about this is, and maybe this is getting a little philosophical.
Again,
I'm a huge fan of Karl Popper, which is an Austrian philosopher of the 19th century. I guess he died in the 80s or something. So it's not so long ago, his philosophy. And I found this very interesting because he kind of said that the scientific method, he was describing the scientific method. And he said, you can never prove a theory. You can only falsify it, right? You can only prove it's wrong. You cannot prove it's right, right? And this is something that brings together theory and the empirical world, right? Practice, right? And I find that so funny that many engineers or many people that are actually trained in science do not follow that process. They really think the theory is over and then the implementation happens and then you're done, right? And this is not how it works. And theory needs to be flexible enough, right? Because the real world needs always be there to test it against, right? To learn, right? To improve, right? And maybe that's a German thing. This is our Germany, the philosophy that many people carry around in their heads is too much influenced by Hegel and Marx, in my opinion. Sorry, okay. Now we get a lot of comments on the under our YouTube channel here. So Karl Popper was way more pragmatic, right? And this is why I like him so much, right? It's the real world is your proof, not what you think, not what other people say. It's the real world. Does it work in the real world? And this is what you work against. If that's not the case, you will fail. Right. And then last but not least, we wanted to end with something positive. And that positive is there is no perfect software. It sounds negative, but it's actually a positive thing. So that means in the real world, leave your perfectionism back home, because you will never create something perfect, right? You will create something that is valuable to customers, that will solve an issue, right? You will not solve all the issues in your field at once, right? Never gonna happen, right? So be satisfied with a outcome that is satisfying customer, you can make money with, you can sell it, and be satisfied with that state, and not try to implement 100% in every detail the exact theory you had in mind. If you try to do this, it will take you forever.
Yeah.
Right. So this is something that also you need to learn. And what I always add, or what one of my favorite sayings basically is, diamonds are only made under pressure. What does that mean? This is when I did my PhD, towards the last couple of weeks, right? I felt that pressure, right? I wanted to be, finish that stuff, and I felt that pressure, and that helps you to focus, right? If you would have all the time in the world to work on something, you basically will fail, because you will not focus on the most critical things, right? Others will be faster than you. Others will be better in the actual solution than you, because they are able to focus on something. If you don't have a deadline, if you don't have a goal that you're working towards, right, then it's, psychologically speaking, a too comfortable situation to really come up with a really cool solution. So pressure actually helps you, right? And that sounds harsh, but it's actually something you can use, right?
It's also the magic sauce for many startups, and we encounter it at the moment. We have
definitely
a couple of money left,
Yeah.
and we know until when it lasts, and until this date we need an investor or customers. And without these limitations, you would not work on the investors' spreadsheets now.
Yeah, of course. Yeah, so that is, the pressure helps you, and you need to use it, right? And it helps you to focus on the most critical things, because a great solution is solving the critical things, is solving the most relevant part of the problem, right? And then once you gain traction, then you can add later, right? You can add stuff to it, but don't waste your time by thinking about a lot of stuff at once and try to implement everything. Right? That's not how it works.
Yeah.
Right.
Okay, with that said, thanks for listening. Thanks for watching if you're on YouTube. If you have more experiences that you want to share with us where theory met practice or practice met theory, leave us a comment, give us a thumbs up, and see you next time.
And please ignore my Karl Marx quote there. See you next time.
Right. Bye-bye.
Bye-bye.